So we're going to start a new chapter, chapter 2 on functions, and I want to begin by making clear what we understand a function is, what a function is and what a function isn't. Because some people will say, oh, a function is just a graph that passes a vertical line test, or a function is a formula. It's a little more general than that. You can have functions with no graphs or formulas. All you need are two sets and a rule or a relation that assigns an element in one set to a unique element in another set. And that's what this definition says. It says if x and y are non-empty sets, a function f from x into y is a relation or a rule that associates each element of x with exactly one element of y. And so you have the whole thing, you want to remember there's this whole idea of inputs and outputs. And the inputs can be anything, the outputs can be anything. The only requirement is that there's exactly one output for each input. And the inputs are called the domain of the function, and the outputs are called the range. And we have this notation, which we'll sometimes we'll use, most of the time we won't. And as I said, these inputs and outputs, they could be numbers, or they could be people, or it could be chairs, or any objects. It doesn't matter. So as an example, or a few examples, think about your grades, okay? At the end of the semester, I'm going to assign a grade to each one of you, okay? So basically, there's for each student, so the grade defines a function from the set of students, so that's this class, to the grades, which would be A, B, C, D, and so on. And I've talked about in the syllabus how I assign them. But even if I assign them randomly, this would still be a function as long as I just give one grade to each student. Okay. Another example, let's say everyone has if you're a music fan, maybe that you have a favorite song. Okay. So if we took a set of music people who like music fans, ask them what's your favorite song, and they give us exactly one song, then that's also a function. Or if you go to the grocery store and let's say you make a list of 5 items. There are 5 items on your list. You don't realize this, but you actually created a function from the set 1, 2, 3, 4, 5 to this set of groceries, because basically let's say if the first thing you write down on your list is eggs, well this is a function that sends 1 to eggs. And let's say the second thing is bread, you say 2 goes to bread, and so on. Okay, so every list is essentially a function, it's just that the inputs are going to be positive integers. Okay, and we have this certain notation here. We have we say that f of x. If x is an element in the domain, then we say f of x is the corresponding output. So if x is the input, we say let f of x be the output. And again, the number in the parentheses, or whatever's in the parentheses, is the output, is the input, and the whole thing is the output. So here's a function that sends 1 to 5, 2 to 4, and 3 to 6. So we would write f of 1 equals 5, f of 2 equals 4, f of 3 equals 6. We're not doing any multiplication. This is just notation. This f of 1 is one single entity. Okay, and we're saying just this as is the output. The output, when the input is 1, the output is 5. That's all this says. Okay. Now, in most of the functions in this course, let me get my thing straight. There we are. Most of the functions in this course will be will involve numbers. Okay, and the functions will involve numbers, meaning the domain and the range will be numbers. So we're going to let, in this case, we're going to let x and y be be subsets of the real numbers. And then we rewrite f of x to be we say that that's the value of f at x. Again, in the larger sense, it means that when the input is x, the output is f of x. But we say this means the value of f at x. And then the domain of a function f represents all possible inputs. And in this case, it's all the numbers that we can substitute in for x and still get a number as an output. And then the range of f is just all possible outputs. Okay, all possible values that f of x can attain. All right, so in this next example, let's look at this equation. What does this mean? Well, this defines a function in which the output is twice the input. Whatever the input is, the output is going to be twice that, or 2 times that. So f of 1 would be 2 times 1, that's 2. F of negative 3 would be 2 times negative 3, that would be negative 6. F of 2/3 would be 2 times 2/3, which would be 4/3. F of pi would be 2 pi. And the domain of this function, well, we can take any real number and always multiply it by 2, right? There's no number that we can't plug in for x and get another number, right? So the domain of f would be all real numbers. Okay, which we can also denote by this interval notation, negative infinity to positive infinity. And if you think about this, the range of f is also going to be all real numbers. Because any number, think about it, any number can be twice some number, right? If you take some value y, well, that's just going to be 2 times 1/2 y, right? So this would be f of 1/2 y. And the point is that y is going to be f of something, okay? And so the range is going to be all real numbers. Now, we can also use this notation to define algebraic expressions, symbolic expressions, okay? Even if the input doesn't have a numerical value. So these last few expressions they're symbolic expressions, but they can be evaluated just using this function this notion of substitution. So f of t, if we plug replace x with t, we would get 2t. F of 3t would be 2 times 3t. And then, of course, we can simplify this as 6t. F of 1 over x would be 2 times 1 over x, or 2 over x. F of x plus 4 would be 2 times x plus 4. And we can distribute the 2 in this case. We get 2x plus 8. Okay. 5 times f of x. Well, we're not really evaluating f of x. F of x, we know f of x is still 2x. So this is going to be 5 times 2x, which is 10x. And then f of minus x would be 2 times minus x, okay, which is the same as minus 2x. Okay. So these last 6 examples, these are really just symbolic expressions. And you do that just by doing substitution.